All right, I'm going to go over solving some radical and rational exponent equations with you guys. I know it's been a couple weeks since we've seen these. I just want to throw this video out there just in case you need help solving the last group of equations on the review. So feel free to stop this video at any point in time, or if you want to go back and rewind and watch again, just so that you make sure you have that process down for those that you need to practice. So I'm going to start off with radical equations first, and then we'll get into some rational exponent stuff. So this equation is going to be hopefully helpful to you, I think, for numbers 24 through 26. I know they don't look exactly alike, but the process is the same for those. So our solving process began with isolating our radical by itself on one side of the equation. So I'm going to get that cubed root of x minus 2 by itself. So I'll go ahead and undo the 1. So I'll subtract that from both sides. So that'll bring me, or leave me with 4 times the cubed root of x minus 2 equal to 8. And then that 4 is being multiplied, so I want to undo that by division. So that will leave me with the cubed root of x minus 2 on the left-hand side equal to 2 on the right-hand side. So at this point is where I want to undo the cube root. So to undo that, I'm going to cube both sides. So this will undo the cubed root, so I'll be left with just the stuff that's underneath. So x minus 2 equal to 2 cubed is 8. And then I'll go ahead and solve for x by adding 2 to both sides. So I get a possible x value of 10 here. But remember that we said we can't just say, okay, x is 10 and be done with it. Remember, we always want to go back and check in our original equation. So I'm going to go ahead and substitute that x value of 10 back up into my original function. So 4 times the cubed root of x minus 2, so 10 minus 2, plus 1 equal to 9. And remember that I'm not solving here, I'm just simplifying. So I'll simplify underneath the root. 4 times the cubed root of 10 minus 2 is 8, plus 1 equal to 9. I'm going to do this part next, so pull down the 4. I'm going to multiply by the cubed root of 8, which is 2. Plus 1 equal to 9. 4 times 2 is 8, plus 1. This is telling me that 9 is equal to 9. So what that says is this x value of 10 is a solution, because when you substitute it back in, it does give you a true statement. All right, let's try another example. Something more like number 23 on the review. So this will be example number 2. So we want to solve the square root of 3x plus 21 is equal to, on the other side, x plus 1. So this one's a little bit different because in this one we actually already have the root by itself on the left-hand side. So I want to undo that root. This time it's a square root. So to undo a square root, I'm going to square both sides. So over here, this power of 2 undoes the square root. So I'm just left with 3x plus 21. And over here, this x plus 1 squared really means that I've got 2 of these. So x plus 1 is being multiplied by an x plus 1. So I'm going to actually have to FOIL that out. So I'll bring down the 3x plus 21 equal to, if I FOIL this out, I'll kind of FOIL it out and combine like terms at the same time. If you need to put another step in there, you can. X squared plus 2x plus 1. So I'm noticing that my x squared is positive over here. I'm going to need to get one side equal to 0. So I'm going to bring this 3x to the other side. I'm going to bring the 21 to the other side. I'll do this all in one step. So minus 3x minus 21. So minus 3x minus 21. Over here on the left-hand side, that's going to leave me with a 0 equal to x squared. 2x minus 3x is minus x. And then 1 minus 21 is minus 20. And then I want to go ahead and factor this. So I'm looking for factors of negative 20 that add to negative 1. So that will give me a negative 5 and a positive 4. Because negative 5 plus 4 gives me the negative 1. Negative 5 times 4 gives me the negative 20. I can go ahead and separate this using my zero product property. So x minus 5 equal to 0 and x plus 4 equal to 0. When I solve each one of these out, this will leave me with an x value of positive 5. Should be an equal sign there. And when I subtract 4, this will leave me with an x value of negative 4. So With this one, it's going to be especially important that we check the positive 5 and the negative 4. So I'm going to erase this. I'll do my check on a clean board because I'm running out of room. All right, so I'll check the x is equal to 5 first. So I'm going to go ahead and set up my root. So 3 times the x value of 5 plus 21 underneath the root over here. I'll also substitute in the 5 over here. So 5 plus 1. This is going to leave me with, on the left-hand side, 3 times 5 is 15 plus 21 underneath the root. On the right-hand side, 5 plus 1 gives me 6. I'll continue to simplify over here. So square root of 15 plus 21 gives me 36, equal to 6. And when I take that square root, 6 is equal to 6. So that means that x is equal to 5 does work as a solution. So x is equal to 5 is definitely a solution here. But we also need to check the x is equal to negative 4. So I'll go ahead and substitute in. So 3 times negative 4 plus 21 on the left-hand side equal to negative 4 plus 1 on the right-hand side. So I'll simplify over here. So negative 12 plus 21 underneath the root is equal to negative 4 plus 1 is negative 3. This leaves me with a positive 9 underneath the root equal to negative 3. The problem here is when I take the square root of 9, that leaves me with a positive 3, and we're saying that is equal to a negative 3. So obviously that is not a true statement. 3 does not equal negative 3. So that tells us that this x value of negative 4 is actually not a solution. So the only solution that does work is the x value of 5. And remember that this process, especially when we have 2 possible answers, is really important to tell us if these solutions are going to work or not. So that's why you really need to check. All right, so that is kind of the wrap up for the radical equations. I'm going to move to the rational exponent equations now. So our example 3, we want to solve out x plus 23 all raised to the 3/2 power is equal to 125. And this should help you with something like 28 on the review. If you're not sure how to do that one, I would just kind of watch this video and get the hang of that first. So our solving process was pretty similar to the roots. We wanted to make sure that we get this term with the fractional exponent by itself on one side. So in this problem, it is. I don't need to do any movement of anything to the other side. So I'm going to go straight to my next step, which would be to raise both sides to the reciprocal of the fractional exponent. And remember that the reciprocal is really just the fraction flipped over. So that means that on both the left-hand side and the right-hand side, I'm going to raise to the reciprocal of 3/2, which is going to be 2/3. Same thing over here. Raise the 125 to the 2/3 power. Over here, my exponents undo each other, so I'm just left with bringing down that x plus 23. And you can drop the parentheses at this point because we've gotten rid of the fractional exponent. And I'm going to bring down the 125 raised to the 2/3 power. So the video that I posted yesterday will hopefully help us to evaluate this 125 to the 2/3 power. I'm going to rewrite this as a radical, and I'm going to evaluate from there. So I'm going to bring down the x plus 23. I'm going to rewrite this 125 to the 2/3 power as the cubed root of 125 raised to the 2nd power. And I'm going to work on the inside of the set of parentheses first here, following my order of operations. So bring down the x plus 23 equal to the cubed root of 125 is 5. Bring down the power of 2. So this is going to leave me with x plus 23 is equal to 25 when I do out that 5 squared. Subtract both sides by 23, and that leaves me with a possible x value of 2. But same thing with the last equations with the radicals, we also need to make sure that we're checking our answers here. So I'm going to go ahead and check in my original equation, substitute back in that 2. So 2 plus 23, all raised to the 3/2 power, is equal to 125. Simplify on the inside here. So 2 plus 23 gives me 25, raised to the 3/2 power, equal to 125. And this, that's okay if you just do that on your calculator. 25 raised to the 3/2 power should be 125. So 125 is equal to 125, which means that the x value of 2 does work as a solution here. All right, go through a couple more examples. So the next one will be a little bit more complicated. Not too much though. So example 4, we're going to solve 3 times 81x raised to the 5/4 power minus 1 equal to 728. So this time we've got stuff around our term with the fractional exponent. So I have to undo this stuff that's going on around. So first thing I'm going to do, add 1. This will leave me with 3 times 81x raised to the 5/4 power is equal to, on this hand or on this side, 729. Divide each side by 3. Remember that the operation between the 3 and the 81x is multiplication. So that'll leave me with 81x raised to the 5/4 power equal to 729 divided by 3 gives me 243. And once I have this term with the fractional exponent by itself, this is where I'm going to go ahead and raise both sides to the reciprocal. So my reciprocal of 5/4 would be 4/5. Raise this side to the 4/5 power. This stuff cancels out over there, so I'm just left bringing down the 81x. And I'm going to rewrite this as a radical as I'm bringing it down. So this will be the 5th root of 243 raised to the 4th power. Evaluate the stuff that's on the inside first. So 81x is equal to, this is asking me what number do I raise to the 5th power to get a 243. That would be a 3 to the 4th power. Simplify that. 3 to the 4th is 81. So I'm left with 81x is equal to 81. Divide each side by 81 to solve here. So my possible x value ends up being a 1. Okay, not done yet though. Need to go to the check. And I'm going to go ahead and substitute that 1 back into my original equation. So 3 times 81 times 1 raised to the 5/4 power minus 1 equal to 728. I'm just simplifying again. I'm not moving things to the other side. So 3 times 81 times 1 is just 81 to the 5/4 power minus 1 is equal to 728. I'm going to go ahead and bring down the 3, and I'm going to evaluate this stuff in my calculator. 81 raised to the 5/4 power. Again, in the check step, we're just making sure that this is actually working. So this is 243 minus 1 equal to 728. Multiply out 243 times 3, which is 729, minus 1 equal to 728. So when I subtract that, 728 is equal to 728. So that works. That tells us that x is equal to 1 is a solution. All right, we will do one more. And this one will kind of be like number 29. I had gotten a couple of comments from people asking about the fraction in this one. Do not let the fractions throw you off. So we will call this example number 5. So I will do 1/3 times x plus 2 raised to the 2/3 power minus 1 is equal to 2. All right, so we've got some stuff again going on around that term with the fractional exponent. I'm going to get rid of that stuff first. So first thing I will do is I will add 1 to both sides. That will leave me with 1/3 times x plus 2 raised to the 2/3 power, and that is going to be equal to 3. So at this point, I need to undo this fraction over here. So I've got a couple of options. I can either divide by 1/3 or I can multiply by the reciprocal of 1/3. So I'm going to choose to multiply by the reciprocal, but you guys can do whatever you are more comfortable with. So I'm going to multiply each side of the equation by 3/1. That's the reciprocal of 1/3. So I'm going to do the same thing over here, times 3/1. So over here, the stuff out in front undoes each other. So I'm going to be left with x plus 2 raised to the 2/3 power is equal to 3 times 3/1 is just 3 times 3. So that leaves me with the 9. And at this point, once I've got this by itself, same process as the last two. I'm going to go ahead and I'm going to raise both sides to the reciprocal of the fractional exponent. So the reciprocal here would be 3/2. And I will do that on both sides of the equation. So over here, my exponents undo each other. I'm left with x plus 2. And 9 to the 3/2, I'm going to rewrite that as a radical. So the square root of 9 raised to the 3rd power is how you would rewrite 9 to the 3/2 power. So I'll go ahead and evaluate the inside there. Square root of 9 is just 3. Raised to the third power. That's going to leave me with x plus 2 equal 2. 3 to the third is 27. Subtract 2. That's going to tell me that my possible x value here is 25. But again, I need to check that. Make sure it works. So I will check that in my original. So 1/3, I will substitute in my 25 for my x. So 25 plus 2 raised to the 2/3 power minus 1 is equal to 2. I'm going to simplify on the inside of the parentheses. So 25 plus 2 is 27. Raised to the 2/3 power minus 1 is equal to 2. I'm going to go ahead and do the 27 to the 2/3. Again, you can do that in your calculator. That's going to be 9. So 1/3 times 9 minus 1 is equal to 2. 1/3 times 9 is 3 minus 1 equal to 2. That is going to tell me that 2 is equal to 2. That means that x is equal to 25 is a solution of this equation. So hopefully these examples have helped you. Now you can go ahead and try numbers 23 through, I believe it's 30 in your packet. Please let us know if you have questions.